All right, so this part that I've underlined right there, it said all of these were 1 to 1, and it probably didn't phase you because you knew how to find the inverse. Okay, that was the simple part. But let's look at what this means to kind of get into a graphic standpoint of what the inverse looks like. Okay, so I've come up with a couple of if-then statements for what it means if if a function is 1 to 1. Okay, so we'll just let you kind of take it in. All right, and this will kind of help you with the definition of what's 1 to 1. If a function is 1 to 1, then the inverse is a function. Okay, thing is, when we find the inverse, just because f might be a function doesn't mean f inverse is a function. Okay, but if it is, that means that function is 1 to 1. Okay, and it's just a term, all right? Now, there's really a much deeper meaning, and I'm not really going to get into it unless y'all just really want me to. Okay, that shows you why we call it 1 to 1. Okay, we might just look at like a brief thing with that. Now, here's what we're getting to here. All right. If a function passes the horizontal line test, then it is 1 to 1. Okay, so we all know what the vertical line test is. Now we're just flipping it and just going the other way. Okay, so we're going to sort of use these two statements to look at a graph and to determine, all right, would the function be, would the inverse be a function? Okay, or is it 1 to 1? Sort of the same question. We're going to look at graphing inverses. Okay, let me put that on there for you. So let's do this. Let's look at a couple of just quick graphs, and let's see if here we can, sort of apply these two statements with them. All right. So let's take something that's just linear, for instance. Okay, nice, easy, linear equation. Okay. So let's call this f, and that's definitely a function, isn't it? Okay. So let's answer this question here. All right. Is f 1 to 1? All right, yes. All right, what's our justification, right? Why? Right, it'll pass the horizontal line test. So is f 1 to 1? Yes, sir, Reed? All right. Now, so what's the meaning here if it's 1 to 1? That means what? We know it's a function. It means what's a function? The inverse is a function. Okay, and so that's like another statement we could add that we're not necessarily asked for, but that's what I'm getting to here. That's the way we write the inverse, right? F to the negative 1. So f inverse is a function because it's 1 to 1. Okay, now let's come up with one. Now let's just look at another one here. Sort of same questions. I'm not going to write everything out with it. Okay, let's just look at a graph let's do a parabola. Okay, so if a function gave me the graph of a parabola, would it be 1 to 1? No. Okay, it would not pass the horizontal line test, would it? Okay, you would touch like a lot of places where you would touch 2 points at the same time there. So this would not be 1 to 1. So if this was some function g, what could we say about g inverse here? Yeah, it's not a function. Okay, y'all get the idea of the horizontal line test and what it shows me here? Shows me whether or not the inverse is going to be a function. Okay, now Y'all do this just real quickly here. Take like 2 minutes, and I'm going to pass out the review to you. Take numbers 29 through 34, those 6 graphs, and answer those real quick. I mean, you just write a yes or no. Make it real quick. We'll pass out the review, and then we're going to talk about how to graph an inverse. All right, so let's see what y'all think about 29. All right, nope. 30, yes. 31, no. 32, no. And this one was the only one that maybe was a little bit confusing. It had a section of it that was a horizontal line. So think about any kind of horizontal line, it's not going to be one-to-one. Okay, anything that's got a horizontal line piece in there. All right, 33 and 34 are basically the same. Both of those were yes. Okay, now, all right, that's usually pretty simple. Okay, it's just remembering those facts here to use your horizontal line test, not to tell if it's a function, but to tell if the inverse is going to be a function. Now, the rest of this here, what we're going to look at is taking a function and graphing its inverse. Okay, so I'm going to start off with an easy one here. Let's do like a linear one first. All right, we should know how to graph a linear equation. All right, so let's start off with a linear equation, and what we're going to look at is how we would graph its inverse. So let's say like 2x minus 3. Okay, let's graph that. And its inverse. Okay, I think we actually do this a little bit in Algebra 2. So it's not too bad here. We're going to start off, let's just graph 2x minus 3. All right, so y'all walk me through graphing that. That's just a simple line. Where do we go first here? Down 3 at our y-intercept. Yeah, there's negative 3. Yeah, rise 2, run 1. So go up 2, run 1, and then there's our graph. Okay, now there's the function. Now we're going to see if we can graph the inverse. What you need? All right, just do Control-Alt-Delete. That'll log it on. Does that work? All at the same time. You got it? Just hit OK. Just hit OK. You don't have to type in a password. All right. Now, let's see if you guys can figure out how to do this. Now, we could write this as y equals, and we could switch x and y and solve for y, and we could actually find the inverse. But here's the thing. If all we want to do is graph the inverse, we don't really have to find what it is. Okay? In fact, you'll notice in your instructions I actually crossed out that step because it's not necessary. All right? So, the original instructions would say, like, find the inverse and then graph the function and its inverse. If you can graph the function, you can graph the inverse. Now, I'm going to see if you guys can kind of figure it out. I'm going to give you some hints here. So, we'll write down these ordered pairs of these 2 points that I plotted here. So, this was 1, negative 1, and this one was 0, negative 3. Now, see if you guys can figure out a way to graph the inverse here from those 2 points. So remember the way we find the inverse, we said it a minute ago, we write it as y equals, and we switch x and y and solve for y. The key thing was switch x and y. Okay? So how can I get the inverse just from 2 points? You're right. Right, so just take the ordered pairs and switch those. Okay? Now, for some people, like when I was your age, I couldn't walk gum and chew, or I can't say it. I couldn't chew gum and walk at the same time, so I would have to write it down. Okay, so you may have to write down the actual ordered pair. Negative 1, 1, and negative 3, 0. But the idea is you just take the ordered pairs and you just switch them. Okay, and that's going to give me my inverse here. So negative 1, 1, if I thought of it that way backwards, that would be this point. And then negative 3, 0 would be this point. Okay, and there are my 2 points to graph my inverse with. All right, because think about it, with a line's not very complicated. All you have to have is 2 points. And so I just picked 2 points, took the ordered pairs, and swapped them. And get my straight edge to work this morning. Monday is never my day. There we go. Okay. All right, so that red line there would represent my inverse. Now, let's see if you guys can notice here some geometry, some symmetry to this. Okay. What was remember we had like symmetry with lines, like if we reflect across the y-axis, we change the sign of x. If we reflect across the origin, we change both signs. What was the line here where you just switch them? Y equals x. Okay, so what happens with a function and its inverse, they're symmetric with the line y equals x. You remember that line y equals x here is like the diagonal line with a slope of 1 that goes to the origin. Can y'all see the symmetry? Okay, like this line, if I reflected it across, it would be that line. Okay, so you got symmetry involved there. Now, let's look at one that's a little bit more challenging here. Let's do a quadratic one. Okay, now on a quadratic, for some reason, I'm going to see if you can kind of figure it out, they're going to restrict you a little bit. Okay, so I'm going to try this one. Let's do f of x equals maybe x squared plus 3. But now I'm going to put this restriction on it here that x has to be greater than or equal to 0. Now, let's just go about our business here. Let's graph it, and then let's graph the inverse. Okay, and we'll look at this, and we'll see if you guys can kind of figure out why are they saying that in this case. Okay, so let's start off. Let me graph x squared plus 3. Now we maybe have to think about this one a little bit since it's a parabola. At least we ought to know it's a parabola anyway. Now, right, it's going to shift it up 3. Okay, so can we just do our t-table for our x squared? And we'll shift it up 3. Okay, so we've been graphing a little bit lately. When I say a little bit, that's like all we've been doing. Okay, you only had like 1,500 problems to graph Wednesday and Thursday, so this ought to be easy because all this one's going to do is just shift it up 3. Okay, the negative 2 to positive 2. Now, what's our parent graph here? What y equals x squared? So this will be 4, 1, 0, 1, 4. So if all we're going to do is shift it up 3, we're just going to add 3 here. So it'll give me 7, 4, 3, 4, and then 7. Okay, and I'm going to need a little bit more graph to this. Hang on. Disregard this line. There's going to be my x-axis. It wouldn't fit on my graph if I didn't move it down a little bit. All right, now let's look at this part though. Let's bring this in. X is greater than or equal to 0. So here's the thing I'm going to do. I'm going to look at my t-table. Anything that doesn't fit this, then I'm not going to graph it. Okay, so what am I going to like rule out when I graph my, that first ordered pair? What else? That second one. Okay, now the rest of them, those are going to be okay. 0, 1, 2, and so forth. Now, let's see if you can kind of predict what's going to happen there. So what's it going to do to my parabola? Yeah, it's going to cut it in half. You're only going to get one side of it. Okay? And we're going to talk about why we would want to do this right here. Okay, why are they saying that? All right, so we got 0, 3. Is that point. All right, 1, 4, and then 2, 7. So we got 4, 5, 6, 7. Okay, let me sketch in my half of this parabola here. So those other 2 points would have given me this parabola on this side. Right. It wouldn't have been 1 to 1 if I would have had values over here, would I? Does that make sense why they're saying that now? And let's talk about something else why we're restricting this. All right, we're getting to the point where we're going to graph the inverse. Okay, so I'm going to do it in red in a minute, and I'm going to call it f -1 for inverse. Now, you don't have to tell me exactly what the inverse is, but look at the function and think inverses here. What's it going to have in there somewhere? What's the inverse of squaring? Square root. And what we say about like the domain of a square root function, it can't be negative. And greater than or equal to 0 means it can't be negative, right? Is this all kind of coming together there now? Now, the inverse, graphing the inverse is actually really easy, because all we have to do is take these ordered pairs and do what with them? Just switch them. Okay? So now, let's graph, instead of 0, 3, let's do 3, 0. So that would be over here. Okay? And then instead of 1, 4, we'll do 4, 1. This is going to run way off my graph here, but we'll look at it. 7, 2. So that's 3, 4, 5, 6, 7, 1, 2. Way up there. And now I can draw that half of the parabola. That's the inverse one. Okay, so restricting it, making x only greater than or equal to 0, allows me to actually look at 2 functions, and not one of them not being a function. So that sort of makes it 1 to 1 for me. Now, do y'all see the symmetry again? See how they're symmetric with y equal x here? I could take this and flop it across. Okay, it's real nice, and I really like that. It's visually pleasing. Now, all right, question? That was my original x-axis, and I noticed I was going to like run off my graph if I didn't lower it down. Okay, yes. Okay, give me just a minute and I'll look at it. All right, let's look. Let me do one more. Let me do like a cubic with you here. All right, and then I'm going to let y'all graph these functions with their inverses here. All right, let's try this one. So we got f of x equals x plus 1 quantity cubed. Okay, so let's graph this one and its inverse here. Alright, so let's get us a t-table over here going. Notice this one doesn't have any restrictions on it. Now, our parent graph there would be x cubed, so give me some values for x here I can pick. Negative, what'd you say? Negative 8. I can see where you're going there because you're thinking negative 8 is a perfect cube. It's negative, but it's not cube root, it's cubed. Okay, if this was cube root, we would go negative 8. All right, 1, 2. Now cube them when we get negative 8, negative 1, 0, 1, 8. So a lot of people get like the cube root and cubed confused, and that's what you were thinking was cube root. Okay. Now, very, very easy transformation. What's it doing? Left 1. All right, so we'll just subtract 1 from all these. So that would be negative 3, negative 2, negative 1, 0, 1. And now the purpose here is not really just to see if we know how to graph this, because we've graphed the crap out of this. Okay? I mean, I'm just, I think I told y'all this like Friday, I'm like sick and tired of transformations. We've been doing it in Algebra 2 all last week, did it with y'all for 3 or 4 days. All right? So that's not really what we're assessing here. We're trying to assess, do we know how to graph the inverse? Okay? And can we graph the inverse without actually finding out what the inverse is? So let me graph this real quick. All right, you got -3, -8, 1. I'm gonna count my y's by 2. Okay. So we got -3, -8, 2, 4, 6, 8. All right, -2, and then -1, -1, 0, and 0, 1, and then 1, 8. So 1, 2, 4, 6, 8. So we get our cube function there. Okay, very sloppy one. Dang, I wish I'd have done a better job than that. It's going to make my geometry look bad. All right. I'm going to do this up. It should be more like that. That looks a little bit better. All right, now, how do we graph the inverse now? Switch x and y, that's it. So here again, if some of you need to here, what you might want to do, if you don't want to get yourself confused, for your inverse, just write down the table and just switch them. Okay, most of you, though, you can just look at it and switch them. So -8, -3, so go, let's see, -1, 2, 3, 4, 5, 6, 7, 8, -3, okay, -2, oh, I was going to do it backwards. I got to do it backwards. -1, -2, all right, and then 0, -1, and then 0, 1. So I've got to change that to what there? 1, 0, and then 8, 1, 1, 2, 3, 4, 5, 6, 7, 8, 1. Right, there's my inflection point. Alright, now because I screwed that first graph up so much drawing it, it didn't look as nice, but do y'all see the symmetry? Alright, you can take one, flop it across the other. Okay. Alright, now that should be enough here to get you through graphing these inverses. All I want you to do in these inverses, I don't have it written over there, was just 39 through 47, just those odd ones. And you notice I scratched out A. A said find the equation for the inverse. Well, if you're going to graph it, you really don't have to know what the equation is to graph it. Because all you got to do is take the ordered pairs and switch them and you got your graphs. Okay? All right, so y'all do that. And you got the review to do. Okay, we got our test will be on Wednesday.